Let's get to the real stuff. Let's show you some demos. We're going to show you an Azure application. That's some work that's being done in the UK right now. I want to invite out Hatay Tuna, who's the solutions architect, to work on this. Hatay, come and join us. Nice to see you. Welcome.
Hello.
So, EOE winner as well. What are you going to show us?
So I'm going to show you an application running on Azure. But before I do that, I just want to warn you that, that our mandate was to develop a scalable, high-performance application. So if I offend any user experience teams, so I apologize. So here's our application.
Looks like a map of London.
It is. It's a map of London. And this is actually a journey planner application that we have developed for transport for London. On the left-hand side, we have the basic parameters, where you want to go from, where you want to get to, what's the day time of the travel. In the middle, we have the Bing Maps to draw the routes and visualize the journey. And on the right-hand side, we have the color-coded London Underground lines that gives us the health of the whole transportation system.
So pretty famous, like, you know, these lines by name. Most people know
yeah.
this.
And these colors are used throughout the platforms in London Ground.
So this map is just subways, or does it include buses as well?
The color-coded grid is all about underground maps, okay. But we do buses and underground.
No horses together. And bicycles?
No. So I'm going to do a quick journey from, for example, Kew Gardens. Let's do.
Looks like the cache got flushed.
Maybe. We'll just do that. Let me actually do that very quickly. Okay, let's go to change the time. See, done. And do automatic mapping, which is good. Let's say Kew Gardens. There you go. And let's see, we want to go to Covent Garden. And Kew Gardens is somewhere that you want to go.
Kew Gardens is out in the suburbs, and Covent Garden's right downtown.
Absolutely. And if you're into flowers, then you
I'm very much into flowers.
So let's go. So on the left-hand side, we have a number of journeys resolved for us. Okay. We bring all the optimum journeys. If there are alternatives, we'll display here. And on the bottom, we see the step-by-step directions that will guide you throughout your journey.
So we've got from A to B in this case.
Yeah.
And as you zoom in, it actually switches to Kew Gardens.
Absolutely. So it's the famous Kew Gardens here. And if you want to see something really cool, here's the plane. And now let's walk through the line. We are on District Line. We are following
the District Line is the green line that we see.
It is the green line,
okay.
Absolutely. And then we have to, let's do this in an arrival query, so it's going to be easier to see. There you go. We are doing a change at Hammersmith to Piccadilly line, the blue line.
These white circles, what does that mean?
So let's zoom in and see. These are actually platforms, so that we have the platform information.
So I've got to go up one level and then go out another level.
Absolutely. Maybe you take escalators, lift, and you walk. We have the information. We can direct users throughout the platforms. Then you take the Piccadilly line and all the way.
It takes you right downtown London.
Downtown London, and you go to Covent Garden. And as we said, maybe you want to take your wife to the Royal Opera House or to a museum. Now, on the left-hand side, our journey says we got to leave by 4:20. That's the UK time, and our journey will take 32 minutes. But as you can imagine, the old London Underground system is very old.
Lines shut down periodically.
Lines shut down, the engineering works, lots of things happen. So I'm going to actually change shoes now and be the operator of the London Underground system. And I noticed a disruption on the London Underground, especially on the District Line, and I'm going to go ahead and suspend the District Line.
So this is going to take the District Line out of service.
Absolutely.
And my journey, I've got a problem because I can no longer take that line. And what happens is
Now it's suspended. If I say get directions again, the algorithm will actually find another alternative route for us. Now we say...
But you show me some purple over here. What is that?
Purple is the bus.
Okay, so I've got to get on my bicycle and catch a bus to get the train.
Absolutely. Take the bus, find the Piccadilly line, and take your journey. And then notice that now you have to leave by 4.
And I have 2 transfers.
And you have 2 transfers now. Now, we use a dynamic algorithm that feeds on real-time data. Unlike Google Transit or others, we don't pre-process. We generate the routes on the fly.
So what's the size of that graph? You've got every station, every bus stop. How big is that?
So every station, every bus, there are around 15 million connections between every station and stop, and the data is for 1 day is around 300 megabytes.
And that's stored where?
In Azure.
That's in SQL Azure, that data.
SQL Azure, and we have an efficient version of it in App Fabric Cache.
So every day you pull it into the cache.
Yeah.
So when we're doing this query over here, we're going from a JavaScript Ajax browser.
So a web service, and web service has access to App Fabric Cache to resolve the journey.
And this is running where?
This is running in Dublin. And actually, we can resolve more than 10 journeys under 110 milliseconds. And actually, it takes more to draw on screen than calculate the routes.
So we're actually drawing, the screen draw is actually done locally, but everything else is done remotely?
Yeah.
Wow. And so this is App Fabric Cache, just sitting above that. And the App Fabric Cache is being updated with real-time status of the various transport schemes.
Absolutely. Absolutely. So, and with that data, imagine that now our journey will take 50 minutes.
Much longer than before.
And imagine that a web-enabled alarm clock or your Mango app can subscribe to the service and actually can wake you up half an hour early.
So you make your meeting.
Yeah, you catch your plane, you catch the meeting. So we can do more than that actually. So I'm going to actually enable District Line again. Since our application is real-time, I can do a lot of cool stuff. Now it is operating as usual. I'm going to get the directions again. Same directions. Now, as you see, I have to change at Hammersmith. But let's assume that I am a wheelchair user. So I can only use lifts. I cannot use stairs. I cannot use...
So for some of us in the room, that would be an elevator that we can use. Plus, the escalators in London, as you know, those old wooden escalators, and then if they can take a wheelchair and they kind of, break down periodically.
Absolutely, absolutely.
Okay.
So if I'm a wheelchair user, so I'm going to actually make sure that, I put my interest into the engine, and I say, get me directions now. Now, everything will work because Hammersmith, all the lifts are working. Now, I'll change shoes again. Okay. Assume that I am the operator of the Hammersmith station, and I notice that the lifts are not working. So I'm going to go ahead and click on the station. I can see which lines are going through. I'm going to click on this button. So this station is no longer accessible. If I click on Save, the engine automatically picks it up. Now it says, actually go through Hammersmith, then change it balance code.
And all of that is kept in the graph in real time?
It's all real time. And our engineering challenge was to make it really fast.
Yeah.
So we work with Microsoft Research on the algorithm, and we rely on...
This is the algorithm to walk the trees in memory.
Absolutely. So if I actually, just move these A's and B's, as you can see...
It just recalculates in real time.
And it's not just one journey. If I actually... Let's zoom in a little bit. If I actually all over, there are multiple...
It's caching each one.
There are multiple alternatives. We run it on Azure because next year there will be London Olympics.
That's about a year from now.
Exactly, and we are expecting 500 million users per month using the system.
Lots of people wandering around with smartphones trying to find a bus or a horse or a bicycle.
Because we have a HTTP REST interface behind it, so applications can actually subscribe and use the system freely. So you see there are a number of this. And let's make it more interesting. Let's add the point.
This is adding a third point.
Yeah, I'm going to add third point. I can add more.
I might want to stop off and go shopping before I get.
Absolutely, you can plan your itinerary, and it's going to be there will be number of alternatives.
Nine transfers.
And there will be real-time feeds coming into the system that we can update and change on the fly.
So this data that's coming over here, by the way, is real-time data from the London transport system right now, because when we were doing practicing yesterday, we were there in the evening, which is actually in the early morning in London, and many of the subways were not running, and so a lot of the results came up as buses.
Yeah, you catch the night buses.
So what was involved in doing this in terms of an architecture and design? How did it actually look?
So the data is actually public, and we take the
large set of access. As that grows, how do we do that? What is the view where we actually start to grow that system? How do we do that through Azure? Are we growing which roles are we growing?
So we have a model. If the number of users and number of queries increase, we will add more web roles and we will add more web services layer as the mobile picks up. But if we bring other transport mechanisms, such as trains or river boats and everything, we will increase the backend. So it's all independently scalable.
And as we can see on this architecture diagram, the endpoints can actually be any device that can assume REST-O data.
Absolutely.
So,
absolutely.
Amazing. This system, the Journey Planner, the web service is in production today. The Journey Planner hopefully will go in very shortly.
Hopefully.
Wonderful. Thanks, Hatay.
Thank you. Thank you.